So unit 2, day 7, it's more just like the second part, or solving polynomial equations again, or part 2, or more practice. And again, with nothing new today, or nothing new like concept-wise, we can just jump into a couple of examples. Find all the roots of f of x equals x cubed plus 12x squared plus 42x plus 49. So even that one's not really, like, we've done cubes before, we've done this type of problem before. So I can't factor that, which means I've got to start guessing roots, but I don't just guess wildly, I guess from my possible rational roots. Factors of last over factors of first. So what are my factors of last? 1, 7, and 49. And factors of first, 1. So the 49 doesn't look real great to try, but 1, 7, and 49, plus or minus, so 6 options. How many roots am I going to have total? 3. So if I can find 1, I'll have this down to a quadratic. I think I mentioned this yesterday. There's something about those coefficients that pushes me away from one type of number. Do you know what I'm talking about? Or did I say that in this class? What am I talking about there?
Positive.
Yeah. When we synthetic divide, it's all add and multiply. So if I stick a positive number there and all of these are positive, there's no way I'm landing at 0. So I'm only going to try the negatives. Now again, if you forget that and you try some positive numbers, I mean, no big deal. You just spin your wheels and waste a little bit of time. I do not want to start at negative 49 because that might get out of hand. Let's start with negative 1. This isn't going well. So that didn't work. So let's try negative 7. And hope that it works, because I really don't want to try 49. I keep saying works. What am I looking for? How do I know if it works? 0 for a remainder. Copy down the 1. Multiply, add. Multiply, add. Hey, there we go. So x equals negative 7 is one of my roots. What do I do with 1, 5, and 7? Yeah, that's now a quadratic. Right, I started with x cubed. I successfully divided with negative 7, so now I'm down to x squared plus 5x plus 7. How would you like to solve that? You can complete the square if you want to. I'm not going to use complete the square. I would use the quadratic formula. But complete the square is perfectly okay. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a So negative 5 plus or minus the square root of 25 minus 28 is negative 3 all over 2. So the negative in the square root comes out as an I. And there's our other two answers. And so I think what's new from yesterday is having to use the quadratic formula. I think yesterday everything kind of worked out okay in our favor. Here we found one that worked, and that got us to a quadratic, and then it was having to use the quadratic formula. Let's do one more, and then we'll work a couple off the worksheet together. Find all zeros of g of x. All zeros of g of x equals x to the 6th. Boo. What does that mean? Before I even continue. 6 zeros. X to the 6th plus 5x to the 5th minus 7x to the 4th plus x cubed. That's actually good news now, right? Like, it looked awful to begin with, x to the 6th. But what can we do? What should be the first thing that we do? Take out an x cubed. X cubed plus 5x squared minus 7x plus 1. So what do I do with that x cubed thing out there? What's that mean? X equals 0. Anything special about x equals 0? It's a triple root. I don't know, seems a little bit weird, but we're not guessing, we're just trying to find the roots. So, I mean, we're not graphing, so we don't, triple root would mean, like on the graph, it's going to do like the wiggle thing as it crosses.
Is it because it's cubed?
Because it's cubed. Because it's cubed means it's a triple root, and a triple root, because it's cubed, will look like a cubic. So all those things kind of fit together. So it looked like this was going to be a nightmare because of x to the 6th, but we found half of the answers already. Like, we know there's 6 answers, we just got 3 of them. So we're pretty good. We got to guess the rest. But this is a nice one in terms of what are the possible rational roots of this one? 1. Well, I hope one of those works because that's all we got. 1, 5, negative 7, and 1. So let's try the positive one, see what happens. All right, all good there. So x equals 1 is a root. And I'm down to x squared plus 6x minus 1. So a little bit like the last one. Remember, that's called the depressed equation. That will not factor. So what are we left with for that? We have 2 options. One that Toby's going to take. That is one of the options. And the other option? Quadratic formula. So why don't you see if you can quadratic formula to get the last 2 answers, and then we'll check and see. So quadratic formula, simplify, and then just kind of double check that we got all 6 answers that we were looking for. All right, let's look at worksheet 7. We need to do a couple of these together because number 3, we have not worked one quite like number 3. So look at worksheet 7, number 3. given that x equals 2i is 1, 0, the zeros are, well, if 2i is a 0, then what else is a 0? Negative 2i. But they all, whoops, I can throw out e then. E doesn't have the plus and minus 2i. And then the last one, I don't know. 1, negative 1, 4, negative 4. I don't know. So how do we usually proceed if we know one of the zeros and we're looking for the other zeros? Synthetic division. Okay. So we're going to do synthetic division because that's what we usually do. Spread them way out because something weird's about to happen. Because what are we going to synthetic divide with? Well, not just I. Either 2i or negative 2i, one or the other. We're going to do both. I guess let's do 2i first. So this is going to get kind of crazy. But if 2i is really a 0, what's going to happen at the end? Should still have a remainder of 0. So that's the nice part about this problem is it's about to get ugly, but I should get 0 at the end. So it's still the same steps. We just need to be extra careful because the I is in there. So copy down the 1. Multiply 1 times 2i is 2i. When I add negative 1 and 2i, what do I get? Yeah, negative 1 plus 2i, or 2i minus 1, either way. Which looks a little bit weird, but okay, let's keep going. Again, the carrot at the end of this problem is there's a 0 at the end, or there's supposed to be. Multiply. All right, I'm going to come out to the side so I don't mess up this multiplying piece. So negative 2i, and then plus 4i squared. Plus 4i squared becomes minus 4. So negative 2i minus 4. Again, the procedure is the same as yesterday, but the trick is there's i's thrown in there. All right, if we add these, what do we get when we add 4 and then negative 2i minus 4? Negative 2i, the 4's go away, so that's kind of nice. And then 2i times negative 2i, that would be negative 4i squared, which would be a positive 4, which makes sense because we're supposed to get 0 at the end. Okay, so it's like, what did that do for us? I mean, it proved that 2i is an answer, but it also gives us some depressed coefficients. So let's now synthetic divide with negative 2i. Copy down the 1. The second time through is supposed to go smoother, so we'll see. We should still get 0 at the end. So 1 times negative 2i is negative 2i. I can add those. Negative 2i times negative 1 is a positive 2i. So those add to 0. And now what do I do with 1, negative 1? What is that? Started with x cubed. We divided twice. So now we're down to x. So x minus 1 equals 0. So x equals 1. Yes, sir.
Why couldn't you just group the equation at the top?
Oh, yeah, I should have done that. Yeah, that worked. Yep. Factor by grouping at the top, and then you'd have found all of them. Definitely a better way to go. Where that wouldn't work is on number 4. So good call, because you could have factored that and that would have been a lot easier. On number 4, I can't see how that one factors. So number 4, we'd have to kind of do the same thing. If x equals positive 3 is a root, then that means x equals negative root 3 is a root. So I can throw out a couple of those answers.
The only one with 4 is C, right?
And the only one, well, yes, but it could be a double root thing going on. So a C is tempting, but I don't know that we can say that for sure. Okay, so same thing. It's going to be a pain with the square root out there. But the process is the same. Copy down the 1. Multiply. Add. Multiply. Okay, so multiplying, if you need to write it out to the side to make sure you don't mess up the, the distribution thing, that's fine if you can handle it. 2 root 3 plus 3. Why don't you take that one and see if you can get to the end. Again, the math is kind of tricky and not so fun, but you know what the answer is supposed to be at the very end, so it provides a self-check. What should we synthetic divide with next? Negative square root of 3. And again, the second time you go through one of the weird ones, your answer should be nice and neat. You should still get 0 at the end, and you should also have integers. So try that one and see if you land at 0.
How did you multiply square root of 3 times 2 plus square root of 3?
How did I multiply? Okay, square root of 3 times 2 plus square root of 3. So again, sometimes it's helpful to write them out to the side. So that would be 2 root 3. And then root 3 times root 3 is just 3. And when I did it, I didn't write that one out. But I did write out the next one because the root 3 times 2, that was a lot to carry in my brain all by itself without writing something down. Although this time through, things work out quite nicely. Okay, we get down to x squared plus 2x plus 1. You can quadratic formula, you could complete the square, or better yet, what would be the best way to solve that one? Factor it. X plus 1 and x plus 1. So x equals negative 1 is a double root. So JD, your observation earlier about having 4 answers was a good thought, but the double root thing kind of messed this one up in terms of just counting the number of answers there were. Because it turned out that negative 1 was a double root. All right, I think that's all the ones that I really thought we needed to work. Do you have any questions as you look through the rest of 7, or if you've hit any on that worksheet that you would like to see? Yes, sir.
So when you're grouping and you get, like, say you take out an x squared, so like say the equation is 2x cubed plus x squared plus 2x plus 1, and then you take out the x squared, but then you get like the same, like you'll take out the x squared, but then it's still 2x plus 1. You have to take out anything. Like, what do you put?
Oh yeah, good call. So like, what do I take out? Because you sort of want it to match the. You want to be able. You want the leftovers to be 2x plus 1. Okay, you do kind of a trick here because you're right. You would like the leftovers to be 2x plus 1. That way you can take out the 2x plus 1. So it's almost it's tricky because it's easy. What do 2x and 1 have in common? What could I factor out of that if you really had to take something out? A 1. It's about the only thing you could do. But that way it looks like, I mean, that's what you were going for, right? Like, how do I make that work?
I didn't put a 0 or not.
Yeah, definitely don't put a 0 because that would wipe it out.
Yeah.
So put a 1 and it doesn't change anything, but it makes the format work for you.
Yeah.
Good question.